Hello everyone. Today we'll be learning how we can make a project on electric usage prediction using Keras Deep Learning tool on the Knime Analytics platform. First of all, let me introduce to a platform called Kaggle where we can download our dataset. So on this platform we can search our dataset. Like for my project I have used the predict wind power output with Keras, this dataset. We can go to the input and from here we can download the dataset. So coming back to our project, so this is the workflow of our project. There are various nodes as you can see we have used, such as column filter, CSV reader, CSV writer, column appender partitioning, line plot, etc. I'll be explaining the purpose of each and every node in the due course of the project explanation. We have also made use of some deep learning extensions like Knime Deep Learning Keras Integration, Knime JavaScript View Labs, Knime Java Snippet. So let us look at the nodes. So the first node is the CSV reader. So this node reads the CSV input file that we give. We can right click on this and click on configure, and from here we can give the path of our CSV file that we want as the input. This is the path of the dataset that we'll be using. So we can click on OK. As I've already imported the file, so this pop-up comes. You can click on OK. So our file will be imported here. So here we can see that there are a few missing data in our dataset. So we'll be required to do the data pre-processing before we can use this data sheet. So we'll be using the next node as data pre-processing. That will just remove all the missing data from our dataset. So after this node, we'll be using the aggregation granularity node. So this node will aggregate the value of the column that we have chosen. Like for example, you can see configure here. So here aggregation column we have chosen as wind speed. So this node will aggregate the values that are present in the wind speed column and will give some output. Same way for the second aggregation granularity node, we have chosen active power as the aggregation column. So the active power column will be aggregated. The values present in this column will be aggregated and we'll get the output. Here we can see the output data table. So this is the output data table after aggregation of the data. So the next node that we use is the timestamp alignment. So this node will align all the columns according to the timestamp. And so here also we can right click and we can check. We can see the data table. So we can see that all the data is aligned according to the timestamp. So and the missing values are also removed. So the next step, here we can see these are aligned according to the wind speed. This column was aggregated wind speed table, and this output was aggregated active power output. So we have to join both the tables so we can get the desired table. So we'll use the next node as a joiner, which will join both the tables. And so this is a joiner. We can see the output here, the filter table. So we can see that this joiner has put both the columns together in a table, wind speed and the active power. So here we can see this joiner, the output, we can take three outputs. The three outputs, first one we have taken as the data pre-processing, and here we can see the visualization. So, this visualization node shows us the output in a pictorial form. We can see for the various timestamps the sum, wind speed, and the active power. The output result is displayed here. We can also see the maximum, minimum, mean values for the wind speed and active power here. So the next thing we do is we extract the date and time fields with the help of extract date and time node. This output is given to a table manipulator that will rearrange the table and remove the date column node. And here this output we can see with the help of a box plot. So here we can see this, it is plotted in the form of a box, the active power and the wind speed, we can see it here. So the output of this table manipulator is given into partitioning. From here the machine learning part starts because we are splitting the data into training and validation sets. So this partitioner, we can see the output how it is partitioned. So this is the first data set, this is the training data set. The partition has partitioned the input table into two parts, the training and validation sets. So here next we move forward, and this we can check the outputs that we have got with the help of CSV writer. This CSV writer, we have to create an empty CSV file, and we can give the path for that file here, and the CSV writer will overwrite anything. If anything is present in the CSV file, it will be overwritten, and we can check the data that has been present as the output in the CSV file. So next, moving forward, we see that we have used the restructure training set and restructure validation set. So here we can see the output, what output we are getting. So again, the validation set is passed through a partitioning node, which has partitioned the data set. So the model architecture for here is the deep learning part comes into picture. We can see that there are four nodes, four layers that are used in this model architecture. The first is Keras input layer. The second is the Keras LSTM layer. Third is Keras dropout layer, and fourth is Keras dense layer. So this output, after the four layers and after the four layers of training, this output is given to the Keras network learner, which will learn about the network. Next, we move to the model training and execution phase of our project. So the next node we use is the Keras network learner, which takes three inputs. The first input is the Keras network variable input. The second is the training table, and third is validation table. And it will use these to get to learn about the network. The output of this node is given to a Keras network writer and the Keras network executor. So the Keras network executor will execute this deep learning network on a compatible external backend that can be selected by the user, and the output of this model executor is given to a column appender. So this will take the inputs from this executor and the inputs from the partitioning the data table, and it will give that to a numeric scorer. So this numeric scorer will give the statistics between numeric column values and the predicted values. So here we can see the statistics. So here we can see the mean absolute error, mean square error, root mean square error, etc. So the output of this executor is also given to a renormalized predictions node, which will take input from the executor and the normalizer. This output is given to a column appender, which will append two columns of two or more columns from two different tables, and this is given to a joiner, which will take input from a column filter whose input is this table, the R input table, and this joiner will give output to a line plot, uh, which will show us a plot between the predicted values and the original values. So here we can see the image. We can view the plot with this option, interactive view line plot. So here we can see the output plot. So we can see the output plot of the active power, electric power. So the blue line we can see that is the actual power, active power, and the yellow one is the predicted value. So with the help of this plot, we can compare the values of the original and the predicted values. So this is all about the Knime workflow and the project that we are doing on this electric power prediction. That's all for this project. Thank you.